Alright guys, hey, this is how videos will work. You'll see the screen, and then you'll see me. I'm writing over here, but it's easier for you just to look at the actual screen that I'm casting with. Again, notes are just for if you want to rewatch them as many times as you want, if you missed class. A lot of times I won't go over all the examples in class, so extra examples, that kind of thing. Okay? We're going to start with, let me make sure I have all my correct settings on. That works. Does this stylus work? There we go. We're going to start with P.1. It's our prerequisite 1. And all we're going to be doing is I can write intervals of real numbers. So this is kind of slow. I'm going to say that. That's why I have the notes already uploaded. We go over it a little bit in class. So really, the best way is to make sure you're in class, paying attention. This is just kind of for that extra practice. Okay. So the first thing we're going to talk about is some definitions. We have A greater than B, right? And that's exactly what that notation means. A is greater than B. And then we have A less than B, right? So this is all stuff we know. So then the other two that we have is this notation. And that means A is greater than or equal to B. Okay? And then our final definition, I guess these are, is A is less than or equal to B. And again, that's exactly how we say it. Our next definition is the trichotomy property, and this is a property that you probably never heard of, but as soon as you see it, it makes sense. So again, this is the trichotomy property. Dots are hard. Like that. Yeah. Let A and B be real numbers. Let A and B be real numbers, so any real number, right? So A and B are just any number you can think of, then exactly one of the following is true. First, A can be less than B. A is equal to B. Or A is greater than B. So I need to write exactly one, which that one didn't get off. There we go. Exactly one of the following is true. Is if I choose any two numbers, it's only going to fit in any of these cases. So if I say like A is 2 and B is 5, then 2 is less than 5. This is the only case that works, right? 2 is not equal to 5 and 2 is not greater than 5. So there's always one and only one of these things that is true. Okay. Our next definition has to do with the notation we're going to learn next. So intervals. Oh, sorry guys. I have to be better about... There we go, there's a dot. I'll get better at it, I promise. Intervals is a set of numbers defined by an inequality. Okay, so a set of numbers defined by an inequality. And we're going to look at some of these now. Move this up. So the first set of intervals we're going to look at, a screenshot. Hold on. Harder to write when your screen stops sharing. So the first set of numbers, the first set of intervals we're going to look at is unbounded intervals. Don't mind the bell. Likes the second one for some reason. So for unbounded intervals, we're going to look at expressing it in three different ways. So we're going to have inequality notation. We're going to have interval notation. And then we're going to have our number line. the first inequality we're going to look at is if x is greater than a. Okay? So what this really means is any number, right, because x is a variable, so any number that is bigger than a. So that means a is my lowest number. So I'm going to start at a. Since it's strictly greater than, there's no equal to, we use a parentheses. Okay. And then we continue on to infinity. And infinities always have parentheses. That's a good rule to know. Okay? So these two things are saying the same thing. Any number bigger than a, and any number between a and infinity, right? Okay, for our number line, what that's going to look like is, this is beautiful. Wherever a is, the way I do it is just, and the way the book does it is wherever a is, you draw a little parentheses. So like that's where a would be on your number line. And since it's every number bigger than that, you're just going to shade this in. Okay, and that's it. Okay, the next thing we have is similarly x. And then x is going to be less if x is less than a. So now this is basically the opposite. Now here, it's every number that's smaller than a. So a is my biggest number. And I'm going smaller than that. And then everything that's smaller than that, again, remember, it's going to be negative infinity. Don't ever put infinity over there, right? Infinity is the biggest number you could possibly be. Negative infinity is the smallest number you could possibly be. Okay, so it's negative infinity to a. Then for our number line, again, very similar. We're going to draw our number line here. And again, I'm going to put a parentheses where there's a, but it's actually opening up the other way, right? Because I'm going to open up to the side that I'm going to go to. It's going to be on that side, and I'm going to shade everything in this way. All right, our next one is x, and then it's going to be greater than or equal to, right, a. So this is very similar to this one up in red here. The only thing I've added is that it's also equal to. So again, everything is bigger than a. My smallest number is a, except now I can be a. So all I change is that instead of a parentheses, it's a square bracket. Okay? So the square bracket is the same as with the equal to, and the parentheses is the same as just the strictly greater or less than. Okay? And then we're still going up to infinity. So we create long line, number line. And then same thing here. When I'm writing where a is, I'm going to put a bracket where a is instead of a parentheses. And then again, since it's going up, it's shading this way. Our last one, x is less than or equal to a. Colors. Especially in remote learning, I'm trying to be super good about using like correct colors so we can kind of see where everything comes from. X is less than or equal to a. So now it's the same idea as this one, right? It's everything less than A, except I can also be A. So my largest number is A. I put a bracket. And this side is that negative infinity, right? We're coming from the lowest number until A. And again, we can number line it. Shut my door there. Shouting off. And again, it just goes the other way, right? It goes to whatever side like you're going to be shading. So those are all of our unbounded intervals. What I'm going to talk about is our, if it could be anything. So we call it all real numbers. Oh, it's so new. So if we're talking about all real numbers, what we write is that it's from negative infinity to infinity. Okay, so that's everything. And if I was like to create a number line for it, I would literally just shade in this whole number line. Right? So the whole thing just gets shaded in. Okay, so that's our unbounded intervals. The next one we're going to do are our bounded intervals. I'm going to make this pinned. You can always see my colors. That might help speed things up a little bit. Okay, so we're going to look at our bounded intervals. We're going to kind of use the same notation. So unbounded, the reason we call it unbounded is because they always go to infinity. It only has what we call as one end point, right? It only had the A. It either ended at A or started at A. Bounded intervals have two end points. Okay? So I'm between two numbers. So for example, I can have A less than X. Oh, this is so much quicker. Now we're going to keep this, which is less than B. Sorry guys, still learning. So this is any number that's between A and B. So for example, if I had like A was 5 and B was 10, I could do 6, 7, 8. But not only that, it's any real number. I could have 5.1, 5.11, 5.0001, right? Anything that's between 5 and 10. So again, what's your smallest number here? My smallest number is A. So I start at A, and it's strictly less than, so I use parentheses. What's my largest number? My largest number is B. And again, it's no equal, so it's parentheses. Again, we kind of learned about this type of notation last year. It looks like a point, but it's not a point. It's A through B. And then making our number line. Wherever A is clearly a smaller number than B, so we'll put A there. We'll put B over here. They have parentheses, so they're kind of like going around what's between them. And then everything between them gets shaded. Also something like A less than X, which is less than or equal to B. Okay, so you can have it be one-sided. One can be strictly less than, and one can be less than or equal to. So then again, very similarly, this notation, okay, well, A is my lowest, and then it has a parentheses because it has no equal sign. B is my highest number. It has that equals, so I'm going to do a bracket. Nice little number line. Very similar. A is parentheses, and B is bracket, and I go between the two. Similarly, I can do it the other way. I can have A less than or equal to X, and then that's just less than B, no equal sign there. That's a less than symbol. In this one, my A is going to have the bracket, and my B is going to have just a parentheses. Drawing my number line, A has the bracket, and I guess I should label these. B has the parentheses, and I shade between them. Our last one would be A less than or equal to X, which is also less than or equal to B. So here my A has a bracket, and my B has a bracket. A has a bracket. I wish I never put any of my B's down. And those are our bounded intervals. Now this chart to kind of see how all of these things relate in a quality notation, interval notation, number line, and then we're actually going to write a description as well. Okay? So, as we saw, if x is less than 3, that means my biggest number is 3, right? So an interval, that's my biggest number, and then it's strictly less than. So then, since things are smaller than it and it has no other type of number, that was supposed to be this. Right? It's negative infinity to 3. On our number line, we kind of see the same thing we did before. I tend to always put 0 on my number line, so we kind of just have a starting place. And then we need that 3. Sure. Right? It's going to be everything less than 3 gets shaded in, right? So then how do we describe this? Well, it's exactly what I said. It's the real numbers less than 3. All right, our next one is negative 1 to 4. We have the interval. Well, I'm starting at negative 1, right? And I'm ending at 4. And since it's parentheses, it's strictly less than 1. And then this one's a bracket, so it's less than or equals. So you get negative 1 is less than x, which is less than or equal to 4. For our number line, again, I'll put 0 in the middle. So -1 with a parentheses is probably right around here. And then 4 with our bracket is probably right around there. I'll just yellow. And again, we shade between the two. Okay? And again, how do we write this? Well, I'm going, right, I'm starting at -1 and I'm going to 4. So I'm just going to pretty much say that. The real numbers between -1 and 4. The one thing we do need to remember is that it is including 4. So we always, any of the two that have like a bracket, just right off the page, we have to say that we're including that number. So the real number is between -1 and 4, including 4. All right, looking at our next example, right, we're given the number line. We're going from -4 to 0, okay? And you can see both of these are parentheses. So if I'm going to write it, I'm going to say, okay, I have one side that's -4. That's going to be strictly less than, because it's parentheses, our x, which then on this side is going to be strictly less than 0, again, because that's a parentheses. So we have parentheses on both. Same thing here, right? I have a parentheses, -4, comma, and then it's 0, also with parentheses. Our description is the same idea here. Well, we're writing it this time. The real numbers between -4 and 0. All right, our last one, we're given the, or not our last one, the real numbers greater than or equal to 0. Okay, so what numbers are greater than or equal to 0? Well, it's only one endpoint, so it's an unbounded interval. So our x is going to be greater than or equal to our 0. Okay. For interval, again here, 0 is our lowest number, right? We write our unbounded intervals flipped sometimes, so we have to be very careful. But x is bigger than it. So 0 is actually our smallest number, and then we write our parentheses. And we're going up to infinity then. Okay. Drawing our number line. 0 is the number we're using, so I'm just going to put my 0 in there. And we shade everything bigger than it. And we have our real numbers greater than or equal to 0. Okay, 6 is less than or equal to x, which is less than 3. Our interval notation should be pretty simple here, right? We have our 6 with our less than or equal to, so we're going to have a bracket with 6. And then we have x is less than 3, right? So we have 3 with a parenthesis. So we're going from 6 to 3. Our number line that doesn't make any sense. I think I'm missing a negative in here. I probably typed it wrong. So let's pretend that this 6 has a negative in it. Otherwise, 6 to 3 doesn't make sense. Okay, so we're going from -6 to 3. So if I put my 0 in my number line, and the -6 is probably all the way over here, and 3 is probably right around here. And again, we can highlight between the two. How do we explain this? Well, again, we have the real numbers between -6 and 3, including -6. And that's over there. Okay, so we're not including 3, we're only including -6. All right, the next one is the real numbers between -2 and 3, including -2 and including 3. Okay, so we're going between -2 and we're including both of them. So that's a good thing to point out. So I'm going to start at -2. I'm including that, so it's going to be less than or equal to. We're also including our 3. Hello? And then we're also including 3. So that means we're going to have that less than or equal to 3. Same thing with our interval here, right? -2 is going to have the bracket. 3 is also going to have the bracket. Number line, I'll put 0 on it. A bracket with -2. A bracket where 3 is. I'll shade in that space between them. All right, last one, -infinity to 4. So, again, 4 is our biggest number. Everything's smaller than that. So again, this is an unbounded interval, so that means we're going to do x, which is less than 4. But it also is a bracket, so it's less than or equal to 4. Okay? And then for our number line, again, I like to put 0 on it. That's a horrible 0. Since we have this 4, again, it's a bracket. Calling me for lunch, so lunch showed up. All right, so it's everything less than 4. So I'm gonna shade in. All the things less than 4. Okay? For our description, last thing, it's the real numbers. Less than or equal to 4. Right? So it's exactly how we wrote it in that definition at the beginning. Okay? And that's it. Have a wonderful day, guys.